Hello everybody, this is Christopher Chen, Integrated Vineyard System Advisor for Sonoma, Mendocino, and Lake County with University of California Cooperative Extension, and today we're going to answer some frequently asked questions about growing grapes. In this video we'll cover vineyard establishment, irrigation requirements, how to fertilize your vine, pruning a grapevine, how to identify different grapevines, and pest and disease prevention. So let's get started, and I hope you enjoy the video. So when establishing a vineyard, whether at home or for production purposes, there are often questions about soil and plant materials that should be addressed and are frequently asked. So one of the questions we get asked regularly is, how do I prepare the soil for planting my home vineyards? Preparing soils for a home vineyard can be daunting. However, there are several key components to address that will make this process easier than you thought possible. Texture, compaction, structure, permeability and infiltration, pH of the soil, the nutrient composition of the soil, what pests and diseases are present, and the water holding capacity of the soil are just some of the many options that you have when assessing your soils. So we'll get into those. First off, ensure the soil is loose and check what your soil texture is like. The ribbon test works well, and we'll talk more about that in a bit. Checking your soil texture can help you determine how much water the soil might hold and how easy or difficult it will be for grapevine roots to grow and explore their surroundings. Soil texture can tell us a lot about how a plant will grow there. Sandy clay loams and sandy loams are highly beneficial to growth of perennial plants. To check the texture of your soil, you want to take a sample from the soil about 6 inches down and slowly add water to it. It should look like brownie batter when enough water is added, but not drip water. If you add too much water, this will not work. Once wet and malleable like clay, roll it into a ball and slowly squeeze a ribbon between your fingers. Try to get the ribbon as long as possible before it breaks. Once the ribbon breaks, measure how long it was right before it broke. If that part of the ribbon is 1/2 inch to 1.5 inches, you have a loam. Sandy loams are closer to 1/2 inch and clay loams are closer to 1.5 inches. If the ribbon is less than 1/2 inch, your soil has a lot of sand. And if it's greater than 1.5 inches, your soil has more clay. Sandy soils tend to have great water permeability but low capacity to hold onto the water, while clay soils can hold onto water too well and create waterlogged conditions. Ideally, your soil will fall into the loam category and have characteristics of both sand and clay. Another key feature of soil is the ease with which water enters and moves through it. Check the soil permeability and infiltration rates by placing a bottomless 1-gallon bucket over the soil, situating it into the soil so as to prevent water from leaving it, pouring in 2 liters of water, and timing how long it takes for all freestanding water to be absorbed into the soil. This will tell you how easily your irrigation water will reach the root zone and can help you estimate how long it will be available to roots in the soil. Avoid compacting your soils. This will reduce the water infiltration rate of your soil and will make it harder for roots to explore. Limit excessive foot traffic or driving of heavy machinery in the vineyards. Once you know how fast water moves in your soils, it's a good idea to find out how much water is going to stay in your soils once you irrigate. We can do this by measuring how much water the soil can hold, or its water holding capacity. Begin by ensuring you have dry soils. Do not try this with a wet soil. Take a metal can or other container with known liquid volume and make sure both ends are open. Force the can into the soil with as little hammering as possible, and remove it without disturbing the soil too much. Now weigh the can with the soil in it. Make sure that your soils are dry when you're doing this process. Now place the can over a grate or strainer to prevent excess soil loss. Measure out 1 liter of water and slowly pour the water into the top of the can, pausing every 200 milliliters to observe if the water has begun to drip from the bottom of the can. Catch the water that falls out in a pan or bucket, and continue to fill the can with the entire liter of water and catch the water that drips out. Once the can stops dripping, measure the volume of water that flowed through the can. It should be less than the 1 liter you started with. You can now weigh the waterlogged can to find the soil's field capacity, or how much water it can hold. This is the difference in weight between the waterlogged soil and the dry soil that you started with, for the volume of that can. Soil pH is important to root health and nutrient availability. Some nutrients are more or less available to a plant at different pH levels. You'll want to test your soil pH before planting grapevines. Use a mud slurry and some pH strips to do this. Ideally, it's somewhere between 5.5 and 6.5 on the pH scale. If your soil is too acidic, with a pH less than 5.5, you can add lime or calcium carbonate in small amounts to raise the pH to a more basic level. If your pH is too basic, greater than 6.5, you can reduce it by adding elemental sulfur, aluminum sulfate, or sulfuric acid, but be careful because this may be hard to reverse. The elements and nutrients already present in your soil should be tested for by a trained lab. To do this, sample 8 to 10 areas per acre you are planting, and if this is a smaller vineyard, 5 samples should do. Schedule a sample submission and soil nutrient test at your local soil and/or plant diagnostics lab. Sample according to their guidelines. Sourcing vines for planting is an important factor in the health and longevity of your vineyard. Healthy vines will live longer and be more productive than vines that were diseased when they were planted. No matter what kind of grapevine you plant, it should be grafted to a grapevine phylloxera-resistant rootstock. This is essential to ensure your vine survives the feeding of phylloxera on its roots. Choosing a rootstock is an important process and should be based on your local climate and the vigor potential of your soils. Please see UC A&R's Grapevine Varieties in California publication for some good recommendations. When choosing a scion, it's important to note the temperature index of your region. Some scions are better adjusted to heat, while others prefer cooler, foggy climates. However, this often comes down to personal preferences of the grower. Grapevine starters can be purchased in a few forms, but the two most common are green growers and dormant planters. Green growers are actively growing seedlings and require water immediately when planting. Dormants are often hardier, but still require water after planting. Whatever you decide, make sure you purchase certified virus-free stock when planting a vineyard. This will help prevent vine decline from diseases that began outside of your vineyard and were carried in with new plantings. Foundation Plant Services sells certified virus-free stock. Vineyard irrigation is often a dance of too little or too much, although it's easier to over-irrigate than under-irrigate a grapevine. Luckily, watering requirements for grapevines change based on the season. In a Mediterranean climate like that of California, winter rains help recharge the soils for the coming season and no irrigation is required. In early spring, the soils should still be charged from winter precipitation, and irrigation can be minimal. However, in cases where there was little rain in winter, you might want to irrigate in early spring. By late spring, a grower will want to irrigate at 100% evapotranspiration replacement, or about 6 to 10 gallons per vine per day. By summer, the vines have gone through veraison and can be irrigated at a deficit. Once veraison occurs, grapevine berries are mostly fed by phloem and require less water to grow. 4 to 6 gallons per day per vine should be sufficient. By late summer, it's good to return to 100% irrigation replacement to help prevent berry shriveling before harvest, and to help the grapevines prepare for autumn dormancy. Once leaves fall off the grapevine in autumn, no more irrigation is needed. During this time, vines are entering dormancy, don't transpire, and don't really need the water. One of the common questions that we get is how do new and established vines differ in irrigation requirements? Well, in the early years of a vineyard, young grapevines need full irrigation throughout spring and summer. This helps develop strong roots and will increase the lifetime of a vineyard. Once the root system is established on a young vine, about after 3 years, the irrigation schedule previously presented is applicable. So now we're going to talk about fertilizing your vineyard and a few key elements that we use to make sure that the vineyard's healthy and happy. So how much nitrogen should I apply? Well, nitrogen is easy to overdo. Too much nitrogen will promote too much vegetative growth and direct the vine's resources away from fruit ripening. Too much vegetation also leads to excessive shading of the fruit zone, further reducing fruit ripening and quality. Apply nitrogen sparingly in the late spring and only before fruit sets occurs. Apply somewhere between 50 and 80 pounds per acre of pure nitrogen. And remember, some forms of nitrogen are more readily available to plants, but are also more readily available to soil microbes. Nitrate tends to act more as a slow-release form of nitrogen in the soil. About half of the nitrogen you put onto the soil will go to microbes and be released to the atmosphere as N2 gas without ever having reached the grapevine. Make sure you know how much of your chosen fertilizer is pure nitrogen compared to the compound it may come in. This is important when calculating how much of a certain compound you want to put on the soil to reach a certain nitrogen level. For instance, nitrate is about 23% nitrogen, ammonia 82%, ammonium nitrate 34% nitrogen, and urea about 46% nitrogen. Potassium is another essential macronutrient for all plants and is required to maintain transpiration and prevent water stress. It can be applied by mixing fertilizers with irrigation water. Potassium has many roles in the health of a grapevine and should be applied before veraison at around 10 to 15 pounds per acre. But be careful how much you apply because excess potassium can slow water infiltration into soils. Just like with nitrogen, potassium comes in many forms, and you want to know how much potassium is in your fertilizer. For instance, potassium sulfate is 45% potassium, potassium chloride 52%, potassium nitrate 38%. Make sure you know these numbers when applying to reach your desired potassium concentrations. Of the big three nutrients in most general fertilizers, NPK, phosphorus is the one plants need the least of. Phosphorus is an essential micronutrient for all plants. However, it is easily fixed in the soil and sometimes difficult for grapevines to acquire. Often, mutually beneficial relationships with fungal mycorrhizae help grapevines reach soil-bound phosphorus. You don't need that much of it when you're applying it to your vineyard. Phosphorus should be applied in small quantities along with potassium fertilizers. Because it is bound in the soil and not highly mobile with water, it should be applied near the grapevine roots. There are many other nutrients that are considered essential for grapevine health and vigor. Zinc is one, which will help to prevent shot berries, or small berries that never grow or ripen, when applied in small quantities. Calcium should be applied every couple of years and can be incorporated using powdered gypsum. For more information on grapevine nutrient management, please see Grapevine Mineral Nutrition by Peter Christensen. Pruning grapevines can be as much of an art form as a science. Establishing structure and form while also pruning for proper yields are essential aspects of the practice. And there are some general guidelines you should follow when pruning a grapevine. Vines should be pruned in mid-late winter when the vines are dormant. This helps ensure that the remaining buds receive all the carbohydrates produced by the vine once bud break occurs in the early spring. Early to mid-February is a good general time to prune grapevines for the next season. However, it is best to not prune until the last frost occurs in your region. The buds on a grapevine break out from the shoot tip to the base of the shoot. Once grapevines are pruned, they are more likely to start breaking bud on the buds you want to develop into the season shoots. If a frost occurs and those buds have already started growing, you may lose those shoots for the year as the cold will kill off any green tissue on grapevines. To prevent this, it is recommended that vines are double pruned or pre-pruned. This process entails pruning each dormant shoot down to 4 buds in early February and waiting for temperatures to stabilize above freezing each night. This helps ensure the vine against random late frost events by establishing 2 sacrificial buds at the top of each spur. Once the last frost is passed and it's safe, the grower can remove the 2 upper buds and leave a 2-bud spur to grow 2 shoots for the rest of the season. Since we went over when to prune, we should cover how to prune a grapevine. Pruning techniques of grapevines vary depending on the way the vine was trellised and trained. The 2 main pruning designs are spur pruned and cane pruned. When spur pruning vines, our goal is to establish permanent points of growth on the cordon. These are vines that have been pruned to have renewal spurs at each growing point and can be head trained, as in a goblet, or cordon trained, or trellised. Typically, vines will form arms in the areas where shoots will grow and then be pruned back each season, similar to stacking new vehicle registration stickers on top of the old ones. These arms each have 2 shoots growing from them during the growing season. Once fruit is harvested and vines have gone dormant, growers should remove the shoot that was vertically higher up on the arm and then prune the lower shoot back to a 2-bud spur. This 2-bud spur will serve as the growing point for next year's 2 fruiting shoots. Repeat this process each year and try not to let the arms grow too tall with successive annual pruning. Excessively tall arms are subject to accidental mechanical damage from vineyard equipment and machinery. The other common pruning style is cane pruning. Cane prune vines are typically head trained, which makes them look like small trees, and are grown on a trellis system. In cane pruning, the most common technique is called the guillot system. In the Guyot system, canes are selected from the upper part of the trunk. Typically, these canes are 3/8 to 5/8 inch in diameter, or about the same as a pencil, were exposed to the sun during the prior summer, and are cylindrical in shape, not flattened. Canes that are too thick can have blind buds that will not grow into productive shoots the following season, while canes that are too small will also have limited growth due to their lesser growth capacity. Once a cane is selected, it should be pruned down to 8 to 10 buds, leaving one extra bud to be tied down later. This cane is wrapped around the trellis wire and loosely tied down at the furthest point. You should choose 1 to 4 canes for this process depending on the vigor of the vine and the suitability of your site. For every 1.5 canes that are tied down in this manner, the grower should also create a renewal spur. The renewal spur is a 2-bud spur, same as you would leave in a spur prune vine, located below the wrapped cane. The shoots that come from the renewal spur will serve as the canes during pruning the next winter. Once you have established arm positions with a spur prune vine, or selected your fruiting canes and established renewal spurs with a cane prune vine, you should remove all other shoots from the canopy to prevent dense vegetative growth in the summer. So how can you be sure that the grapevine that you purchased is the correct variety? Because most grapevines we grow that produce fruit are one species, it can be difficult to tell them apart. But there are some simple features to look at that might help. The fruit on different vinifera cultivars are very distinct and can help identify the grape you're growing. Make a note of whether your grapevine has white, red, or black fruit. This will narrow down the possibilities significantly. In middle to late summer, also note how large the clusters and berries are, the compactness of the clusters, and the time they take to reach full ripeness. For table grapes, that's about 18 degrees Brix, and wine grapes, about 24 degrees Brix. Clusters might be the most useful identification tool for grapes, but when there are no clusters early in the growing season, shoot tips can help. If a shoot tip is open when growing, where you can see the smallest developing leaf, the grapevine is most likely Vitis vinifera and will produce edible fruit. If the shoot tip is closed like an envelope, the grapevine is likely a wild grapevine or a rootstock cultivar and will not produce fruit. Different cultivars of Vitis vinifera can also be identified by their shoot tip in early spring by color. Leaves on fruiting scions can also be used as a tool for grapevine identification, but not all leaves on grapevines are useful here. You want to select the leaf that comes from the main shoot and is 1 to 2 nodes above the last cluster. These will be most reliable in identification and are known as count leaves. Use features such as leaf lobing, tomentum or hair, leaf size, and the teeth at the edge of the leaf to help identify the cultivar. Guides to help key out the varieties are available online and in printed literature. If your grapevine appears healthy, then you can use the growth capacity or vigor of the vine as another tool to narrow down your identification. Some vinifera cultivars are more or less vigorous than others. For instance, Sauvignon Blanc is typically very vigorous and can grow to look like a large, dense shrub, while Pinot Noir and Pinot Blanc tend to have small canopies with a low leaf density. In cooperative extension, some of the most common questions we are asked are about grapevine pests and diseases. So, let's talk about how to prevent pests and diseases from getting out of control in vineyards. Just like in humans, there are many sources of disease for grapevines. Some of the more common pests, like spider mites and mealybugs, have well-designed measures to reduce populations in a vineyard, while rootstocks were introduced to combat the threat of grapevine phylloxera. But going into detail on each of these is impractical, and there are some general guidelines you can follow when trying to reduce pest and disease pressure. Perhaps the most important preventative measure a grape grower can take is regular and consistent monitoring of the vines. Monitoring your vines for signs and symptoms of pests and diseases is the #1 way to keep them from becoming a big problem. Look for remnants of a pest or discoloration on the trunk or leaves of your vines. As with human disease prevention, hygiene is a key element of keeping a vineyard disease-free. Many pathogens can be transmitted between vines through contaminated pruning shears, hand saws, large machinery, or more. Clean your vineyard equipment regularly and avoid pruning gear touching the vineyard soils. Through regular monitoring for pests and diseases, a grower should be able to catch that pest before it becomes a problem. If you see a vineyard pest start establishing, use integrated pest management measures to reduce their spread immediately. Many pests and diseases can survive on more than just grapevines. Plants that can harbor a specific insect vector or pathogen are known as alternative hosts. These act as safe havens for pests and diseases when feeding on grapevines is not an option, such as during winter dormancy. Know what plants are in and around your vineyard and keep the alternative hosts of pests and diseases out. Often native species can be beneficial to a vineyard's health. Encouraging a beneficial organism's population health and habitat viability can help reduce pest and disease pressure in your vineyard. After all this, if pest and disease damage reaches a level that calls for management, start with the Principles of Integrated Pest Management, or IPM, first. These can be found online at the UCANR IPM webpage. Chemical controls such as insecticides or herbicides should only be used as a last resort in extreme cases. Thank you for asking these questions and utilizing the UCANR Cooperative Extension resources that are available to you. If you have more questions about growing grapes, please contact your local UCANR office. Thank you very much.